My name is Josh Benoit. I'm with the Digital Business Department over at EPLAN, and we're doing Open Line Friday. This is where we answer your questions and we talk about things that we're doing at EPLAN that might, well, be something that you're interested in. As usual, we are recording the session and it's going to be on demand next week on our YouTube channel, which has lots of great content. We have the content from the last Open Line Friday, which we talked about the EPLAN engineering standards with Ian Underhill and Roger, which was fantastic. We have a lot of great Open Line Fridays there, some that Kruno have been on, as a matter of fact. And so actually, Sean, you've been on this, I don't know, this is probably your fourth or fifth time that you've been on Open Line Friday, the first time for Eli. So let me go ahead and introduce you. Sean Mulherrin, back again, our product manager in global solutions and development with EPLAN on a Friday. Thanks, buddy, for being with us today.
Absolutely a pleasure. Love doing these Open Line Fridays.
You like doing them? Good.
I love them. It's fun. It's just
you just committed to 3 more. Right
Through the end of the year, you're going to be booked up now.
Tell me this is not recorded.
Eli Jenkins is our channel sales manager, who Eli started 1 week after me. And I have just a quick story is that whenever I met Eli, I was like, oh my gosh, this guy's all business all the time. I don't know if I can handle this because I'm zero business all of the time. And it's funny because we went out the first few days that he was with EPLAN. We were in Schaumburg and we went out and had some dinners. And I thought, golly, I like this guy a lot. It was just one of those things that you kind of connect with somebody, and that's really cool. I don't think Eli thought the same thing, but that's okay.
I almost quit. Yeah. I was like, they're hiring some weird people in here. So,
so we're only a week apart as far as when we started with EPLAN last year, but it's been a fun ride. And Eli and I, he works on, of course, the channel side, and I work with him with some of the digital business things that we do with that. So this week we're talking about how can EPLAN help with standardization? And standardization is something that we have talked about or alluded to quite a few times. Sean is the guy. I mean, as far as standardization goes, you're kind of the guy with this. Wouldn't you say that you're probably the one that mentions this more than anybody else?
Well, since I started EPLAN 30 years ago, the word standardization has been part of the vocabulary, and it's been a quest ever since to try and get customers, one, to understand what it means, and two, to try and implement them and to use standardization. So it's the concept is genuine, and it definitely has a huge amount of benefits. But the understanding and getting it across to customers and getting customers to accept it and embrace it is a whole different ballgame.
In the current work environment right now, as when we're talking about controls design, how is it done today? What's the behind the scenes for that?
So when we talk about standardization today, it's done in many different ways. People have different views on it. They implement the standardization differently. So it's pretty much all across the board. And by being all across the board, it comes back to there is no standardization, right? And sometimes you need the gremiums, the standards to kind of step in and kind of say, hey, let's just stop all of this all across the board nonsense, and let's just follow some rules and follow some basics. And those standards start to be implemented, but not everywhere at the same time, not in every country at the same level. So it's still work in progress, and it still has a very valid point and a very valid place in the automation design world.
And I know that we were talking on Wednesday because we do a little setup meeting whenever we kind of figure out what we're going to go through. And you mentioned this story about taking someone from 40 hours to 15 minutes. So I want you to tell that story from your perspective, because I don't think I could do a good job of summarizing that.
So the story was from a machine builder, and they had standardized machines with various amounts of options and variants that they would offer their customers. So the sales process would look like the sales guy would talk to their customers. They would look at all of the options that they needed. They would fill out a form. This form would come back to the company. The company would then look at the options that they picked and chosen. They would look at all of the designs, and then they would go page by page through about 160 pages of schematics and remove what was not needed, add what was needed, and it was the same workflow every single time. And of course, once you made those changes, you had to apply those changes. So they would go back into their CAD environment, they would mark up, they would change, then they would go back to the engineer would mark it up again, and then he would find some mistakes. And talking to the engineer is funny because it's like, I've been doing this job for 10 years plus, and every single time I always mark up the same issue because it never gets fixed in the original project, right? So what we decided to do is I sat down with them and I looked at, okay, let's look at those 160 pages of project that you constantly mark up, and let's break them down into little pieces and create a library out of those pieces. And as we were doing that, he was like, well, this is the error I always mark up. So we were fixing things as we were going along, and we created an entire library of basic circuit diagrams. And then what we did is we linked those circuit diagrams with the machine options or variants that were selected. So now what happened after we implemented the standardization and the automation process is we were able to go through the order process or the order sheet that came from the sales guys and then select those same options in the EPLAN environment. And with the click of a button, he could create within 15 minutes 160 pages of schematics automatically. And it was really, really cool because in one instance, it was fixing all of the challenges that he's been having on all of these days that he was just modifying those schematics to. Now he's just looking at an options sheet, selecting the options, clicking on the button, and it's done. So it used to take him 40 hours a week just to fix and clean up the project. So it was actually the machine he was going to deliver, to now creating a sheet, selecting the options, and within 15 minutes, the project was out the door. It was quite eye-opening for me too, because doing the implementation and seeing the results was absolutely fantastic.
Yeah, that's where we talk about efficient engineering,
Absolutely.
and I think that we don't always get the point across. And the stories like this, it's easier for us to tell a customer story and get the point across than kind of explain it in what is sometimes bland terminology. What is efficient engineering? And then we just get into, spewing the same things. Well, let's give an experience. What was an experience someone had in taking it from 40 hours to 15 minutes? I mean, that's huge.
Mm-hmm.
Well,
and that's not the only example, right? There's many others.
The reason for that, Josh, really is like normalcy bias, right? We do things every day and we get so used to doing them that we decide that that's the best way to do it because we've always done it, and there's no harm in that because we're successful today. And that's just not the case. I mean, we can take, the word standardization and really make it fit in any way that we want it to fit. Even with the example of, well, I always fix this error. Well, you could go out on a limb and say, well, I've standardized my process to always go in and resolve that error, right? Well, let's not use it so loosely. Let's take someone like Sean, who's 30 years an expert in doing these things, with a system like EPLAN that is set up to do it, and actually apply some definition of success and some structure so that you get a new result. I don't think we always do that. It's almost a real standardization versus a perceived standardization. We can say our garage is organized if you know where everything is, but in fact, it could be all over the floor, right? So
yeah, that's a good point, where standardization might mean different things to different people. The way that they do it might be standardized for them, but we're talking about across an industry.
yeah.
And the buzzword is standardization right now in the automation world. But what actually does it mean? What are we looking at, and not from an individual perspective, across an industry?
So standardization as a buzzword, if we just take a step back and look at how people work today, you'll have a company that has, let's say, 10 electrical engineers, and they're doing controls design on a daily basis, designing their machines. Well, every single one of their of their engineers has a different background, different habits, different ways of looking at things. And if you give them 15 different blank sheets of paper and you ask them to create a power supply, a simple power supply, 480 volts, 60 amps, and a couple of branch offs, 410 volts and 24, you'll have a drawing, they'll be across the board. I mean, you'll have 15 different results. Some person will use a 1/2 inch grid, some other will use a 1/4 inch grid, one person will use a D size sheet, the other one an A size sheet, the other one will label their components in a certain way because they're used to it, another person differently. So this is exactly where it starts, is the fact that everybody is looking at the same thing from a different pair of lenses. And it's just the way that they've been doing it for years, or bringing their experience from different industries. And the idea is, within that same company, is to stop that all across the board and interpretation. It's just like not having to think about it and knowing exactly, I need a power supply, there it is, drop it in, place it, define your circuit, your size, and you're done. Instead of figuring out, okay, am I going to place it at the bottom left, at the top right, at the bottom right, top left? I mean, those are all things that people on a daily basis are confronted with, which should not be. And another funny story too, in terms of standardization, was we were talking back in the days with Alan Bradley about putting the data in the data portal and having, you know, a standard representation for their PLC cards. And I'm like, well, how are we going to represent this 1756 IB16, which is pretty much the standard in the automation industry from a PLC card perspective? What does it look like on a schematic? And everybody in the room looked at me and like, well, I don't know. Well, from a hardware perspective, it's the same thing, right? You purchase the same part and it looks the same all across the US and even in Europe. It looks the same and it has the same functionality. But when you put it on a sheet of paper, it looks completely different. I mean, one time you have 8 IOs on a page, sometimes you have 16 on a page, sometimes you have 1, sometimes it's on a D size page. So there's really standardization non-existent and is across the board. And it starts there. It's figuring out, okay, what is this supposed to look like, and how are we going to make it available to everyone so they can just pop it in their designs and just run with it. And that's kind of the basis of it, is getting a common understanding of what is a controls document supposed to look like, and what is the most efficient way of laying it out, and what is the most efficient way of communicating the information on that document to everybody that is going to consume that data. And the other challenge I've run into is people think that a schematic is a piece of art. And they just start putting all sorts of pretty pictures and making it look nice. And the feedback, you know, the customer's like, yeah, our customers really like it because it looks nice. And I say, well, is it practical? At the end of the day, what is the purpose of a controls design, a controls document? The purpose of that document is to make sure that it's got two purposes. The first one is make sure that it's built correctly, that everything is wired correctly to the right point, to the right termination with the right wire sizes. And the second aspect is, once the machine is running and if something goes wrong, you want to look in that documentation and you want to be able to find it really, really fast. So artistry and pretty pictures and pretty documents has nothing to do with it. It has to be a functional document in which you can find the information very fast, quickly, and efficiently. And I think to be able to achieve that kind of aspect, standardization is the key.
Yeah, that reminds me of whenever, like in Scouts, whenever my kid had to create an evacuation plan for our house. So he drew the house, and I mean, he did a pretty good job with his artwork. The functionality of how we were going to get out of the house and get to safety, not so great. The implementation behind it and the strategy wasn't so great. So we had to kind of walk our way through that. So looks good, not great functionality. So that one made it on the refrigerator, but we were never going to use that.
It's kind of like the exit sign on this picture is painted green, but the exit sign here in real life is red. Is that the same one? No, I don't think so. We're looking for the green one.
Yeah, there's
Exactly.
a direct link, right, between the standardization and the way that you do things, of course, to the function and fit and effectiveness, but it's the overall quality, right? The overall risk that you're looking at in your project. And if I was a owner or manager of a system integrator out there and all of my design team were doing something different and in their own way, that's going to add a lot of stress to me because I don't know what's going out the door.
Hmm. Yeah, I mean, there's a whole bunch of different consequences that are coming upon non-standardization, right? The first one is reuse. When you have a new project and a new project comes in, where do I start? Well, I've got a project that I did for another customer that was very similar. Let's just go back in those files. Let's copy those files across. And then, oh, there was this other project that had this other part. So you start copying from multiple different sources and everything kind of looks a bit different, doesn't really fit together. So you spend more time trying to make things fit together and cleaning things up than you actually do designing and making the system work.
But do you feel like it's important that standardization is not just in one area? I mean, you have the standardization of the design, but also the parts as well, right?
Absolutely. I mean, standardization has many different facets. And if we look at the controls world and specifically on the electrical controls, standardizing on products and then parts is important. Why? Because first of all, you make sure that you kind of get your customer to know which parts you're going to use, and it's going to be easier to troubleshoot. It'll help you to kind of minimize inventory if you don't have 15 different parts, but you focus on 5 of them that you kind of use across the board. It'll also help you leverage pricing because you're going to order that part instead of ordering 15 different ones. You're going to order that part 15 times. Where it is possible to do so, you should try and standardize on the parts aspect as well. Streamlining order processing so that you know exactly what the price is going to be. You might be able to negotiate better prices because you're purchasing bigger quantities. That's all kind of part of standardization in terms of parts, in terms of
There's so
order.
many intangibles around that too that you listed 3 or 4 things there, but I know of a system integrator who was quoting a job and they did that same model. They grabbed an old project, they started pulling parts and pieces in because it was similar and they made it fit and they pushed it out to try to win the job. And they came back and be like, man, you were way too high. And when they went in and looked at it, there was 4 or 5 panel views that was in the old bill of material that they just assumed was still good. They put it in there, but they were gone obsolete. So the price was about 150% higher on those panel views, which ended up being about $15,000 that was on their quote that they didn't know was already adding $12,000 or $15,000 on top of what their competitors were doing, right? Because they're so open to one, the copy and paste, to bringing in those old things. And they have so many parts that they're dealing with across the board, different manufacturers, different types, that they didn't recognize or have the knowledge of that part in depth to know that it had become obsolete. So that's one example, but there's tons of those across the board that happen day in and day out at system integrators across the US.
Now, from a design perspective, fluctuation is there from one design to the next. Like whenever you're talking about, because I feel like it's almost whenever you have those designers or people that are doing the design work, there is fluctuation, right? But how does that fluctuation affect the end product?
When you talk about fluctuation, you mean the people leaving and new people being hired, right?
No, I'm talking about like if you have 2 people, then are they going to do things exactly the same? Is that
Nope.
is that something that should so in when we're talking about standardization of design, are you wanting it, are we wanting them to do things exactly the same way?
Absolutely, because the funniest thing all the time I hear, or funniest thing, it's a real world thing. It's all of my machines are different. I can't standardize because everything is always different. Every customer is like, yes, he's 100% right. All of their machines, you look at them, they're different sizes, different weights, different colors, different purposes, different functionality and such. However, one thing that they don't look at is if you look at the controls design and you look at schematics are the same over and over and over and over again. I mean, you'll always have a power distribution. You'll always have a power supply. You'll always have a transformer circuit. You'll always have a 24-volt circuit. You'll always have a 110-volt circuit. You'll always have motor starters. You'll always have PLCs. You'll just have plus or minus quantities of them. However, always recreating a new circuit just because you have a new motor and it's a different machine doesn't make any sense because the motor is going to be controlled the same way. You might have, instead of a contactor, you might have a VFD, but now you can modularize your design and you can start organizing your libraries to always place the same thing. And now suddenly the controls aspect really isn't that much different from machine to machine. You might just have 10 more of this and 5 less of that, but at the end of the day, the circuit diagrams should not be an interpretation. It should just be a functional diagram that tells you how the machine is going to work and it's going to be controlled.
And what does that standardized design mean for the company? What are the, what are the pros for that? What the benefits of it?
Well, it's going to be manyfold. I mean, you'll have a minimize of guesswork during design. Like when a user starts opening up an empty sheet, he doesn't have to think, oh, which symbol is he going to use? Where is he going to place it on that page? How is he going to label it? And he just takes the design, the standards that he created, and just pops them on the page and just sets the values that he needs to set. And then he just goes through his design just thinking in a controls environment, say I need a power supply, I need a motor starter, I need a 24 volt DC power distribution, I need a 110 volt power circuit. All of those thought processes are now translated into picking from a library of standards that he can just populate on his designs without having to think of what is it going to look like. It's already defined. The looks and the way that everything connects has already been defined in the standard, so he doesn't have to think twice about it. It's going to be a lot of faster ramp up for new designers. You hire a new guy off the street or somebody that's coming in because somebody left. Now you say, they're your standards. These are all of your standardized circuits. You pop them in, you select your values. Now you've got a guy that doesn't, he's used to designing the old way. Now he can just start off really, really fast and be efficient in no time at all. It's really also a huge foundation for design automation, because if you place those circuit diagrams and you identify which ones you need and what size they are, why couldn't you do the same thing automatically? You say, okay, now you go into the configurator environment and you say, okay, I need 5 motors. The first one is 5 horsepower, the second one is 3, the third one is 3, the fourth one is 5. Click on a button, generate the schematics for me automatically. But you can only achieve that if you're standardized on your controls design, the way that you lay out your schematics, the way that you position them on your document. And that's a huge aspect of it.
Yeah, I think also whenever we talk about people doing this a different way or doing it the old way, and you're building everything from scratch, maybe there's so much room for error. Even if you're doing the same thing over and over and over, the redundancy sometimes it leads to errors, and that's really what you're trying to eliminate in a lot of this too.
Absolutely. I mean, again, at the end of the day, where do the errors go from design? They go into manufacturing, right? When the guy starts building the panel and he manufactures it wrong, well, just the smallest aspect of, oh, maybe I did the wrong holes on my push buttons. Well, suddenly you can't plug those holes back in once you've drilled them. You have to buy a new door. So just a little error up front in the design can be a huge, tremendous cost in the manufacturing. So if you are able to standardize and minimize those errors in the design environment, then suddenly your manufacturing becomes a lot more streamlined, a lot less errors, a lot less cost, and then the quality increases too. So the quality of your panels every time you deliver, it's going to improve the satisfaction of your customers at the end of the day, right?
That's the big deal, Sean, is understanding what those small errors do over time to your customers. And when you have to come back and keep requesting, oh, I need another week to finish this because you misdrilled something or you put the wrong part here or whatever happened, those things build up. Nothing is slowing down in our industry. Everybody wants their parts faster, their panels faster, their solutions faster. So if you can't get on board with that and deliver something that's going to be quick, fast, and then also as close to perfect as possible, then someone else besides you is trying to. So I think it's, almost taking some ownership for these system integrators and panel shops and OEMs to say, yeah, we've been doing this way the whole time, but maybe if we could cut these small things out that we try to hide in the panel shop, we can deliver that solution, but also get that trust from the customer to get more business and more throughput.
You feel like this is like standardization as a selling point whenever Eli, whenever you're
Differentiate
talking to channel.
the thing is also standardization is one aspect, it's a buzzword, but you also have to provide the tools with which you can implement the standardization, right? And then EPLAN is definitely on the top of the list in that aspect where it's prone to standardization. And once you've standardized, you can really go from 40 hours a week down to 15 minutes.
But I like that, Josh. Could you imagine if you owned an OEM or a panel shop, SI, and you brought your customer in and said, let me show you why we're not going to screw up. And it's not because this guy in the corner gets paid more than everybody else.
Right.
It's because of this process that we line out. That would make me feel better as the customer.
Whenever you are saving time, errors, and money overall, and at the same time you're increasing your output, I mean, that's what we're talking about with efficiency right there.
Yeah.
And people are going to keep coming back to you. That's the thing, is that, you know, once they see your process and see that how you do things is much more efficient than anybody else that they use, then I mean, you've kind of set it up to where you're going to have a lifelong customer at that point.
Yeah.
And Josh, are you monitoring the chat? I think there might be some questions in the chat.
Yeah. So the question was, can you explain in simple terms why creating macros is worth it? People may question if the time to create a macro is worth it versus the copy and paste from old projects, which is a good point.
Mm-hmm. And the myth behind that is people always think when I create my macro, I have to start with creating the macro first, putting it in a library, and then from there I can build my projects. Well, every time I go to a customer, I say, no. Just don't think about creating the libraries. The first thing you're going to do is you're going to create your baseline project. You're going to design your project as you would do it. And then once you have your project, then you're going to identify which portions of the project are reusable. Which ones do I see from project to project to project? And then what are the variants in each? And once you have that, then you can start highlighting within that existing project your macros. So the macro creation is really not that challenging because within a switch in EPLAN, I can take a full-blown project, and with a switch, I can change it into a macro project. And by doing that, now I can go page by page and identify which portions of that project are actually my macros. And then I can say, okay, how many variations do I have of that same circuit? So then you can start building it from there. So you don't have to start with an empty page and figure out what's my macro going to be. No, you design your project, you create the first project, and once you have that, then you say, okay, out of this project, how am I going to break it down? And what are going to be my reusable circuits? If we take the other approach that is very traditional, which is copy and reuse from existing projects, when you copy and paste, what is your first assumption? Well, that because it was in a previous project, it's automatically right? There's no errors. Well, not necessarily, because it just depends on how many people have checked it and whether it was thoroughly checked or it was checked at production and not retransferred back into the design. So there's a whole bunch of variables that exist, the fact that it could actually be wrong. But the anticipation of the designer is that it's correct. And then they don't necessarily check it a second time. So they're just going to keep on using those errors and then building up those errors, which is going to create more challenges down the line.
Let me ask you a question, and I want you to, in a second, I want you to explain from your point of view what a macro is, because I think that we don't talk about it enough here at EPLAN. But how many times do the designs get to production and production sees that there's an error and they decide to change something and don't relay that information at all?
All the time.
And so, again, how much more is that creating problems? And it goes back to you saying, well, you copy and paste and you don't know, but it happens probably more than people know.
Oh, absolutely. I mean, it's a daily occurrence, I'm sure, the panel builders, where they kind of look at the drawings like, oh, that he forgot this again. And because he maybe communicated it once before and he keeps on doing the mistake, he just ignores it. Now he's just fixing it himself. But the challenge again is if that person that knows the error now leaves the company and then suddenly another person replaces it, he doesn't see it, then the error comes back down 2, 3, 4 months later without people understanding why is that error actually happening. So it's just a perpetuating motion of implementing those errors when, hey, let's just stop that. let's go back to the basics. Let's create a basic project built on macro library and then start using those macros to build and design the project from scratch. And people think, oh, designing it from scratch, it'll take a long time. But no, if you have the right tools and using a tool system like EPLAN really facilitates the implementation of dragging and dropping those macros incredibly fast and building up a 100-page, 160-page project within a week incredibly easy.
But again, what is a macro?
What is a macro? That's a very good question. We use that term at EPLAN we've been using that term for donkey's years. And the people who look at it like macro is like, I'm not sure I understand what it means. Well, let's go back to the basics. The term initially, I think, correct me if I'm wrong, you can fact check me on this, but it was coined by Excel. Like if you work in Excel and you have a macro in Excel, and the first thing you do when you have macros in Excel, you use the macro recorder. And what the macro recorder does, it records all of the steps you do in Excel. So you go onto a new sheet, you select cell A1 and you copy the content to cell B1, and then you actually implement a formula. So, and then afterwards, once you save the macro, what happens is you hit the play button and it repeats all of those individual steps that you made. And that's a macro in Excel, right? So what is the macro in EPLAN? Well, in EPLAN, what do you do on a daily basis? You create a new page, you take a symbol, you place it, you place another symbol, you connect those two together, you label the symbols, you add a part number to the symbol. Those are all the manual steps that you do while you're creating your schematics. Well, if I save that as a macro, now I can play it again on a new page. I have an empty page, I play the macro, and now it just pops the symbol, it pops the other symbol, it connects them together, it labels them automatically. So in the background, the macro is pretty much exactly the same as what Excel used to do. It just automatically creates all of those steps for you in one swoop motion. So it's really a collection of steps that you take. And in the circuit diagram, it's a circuit. It's a part of a circuit that you can store as a macro. So that's where the term macro initially came from.
And we have, if you look at our engineering standards, there are macros available right there. It's not about you recording those as much as you have those available automatically.
Exactly, and part of the engineering standard task force that we had initially, I listened to the Open Line Friday. Ian Underhill was one of the person that created all of the library for North America, which is really, really cool. And one of the ideas initially is instead of always giving a customer an empty page, why not give him a library of already predetermined circuits? And we went through hundreds of different DWG drawings or CAD drawings representing power supplies, motor starters, power distributions, and what do they look like? And out of all of those, trying to figure out, okay, what is the most common way of representing those? And now we build a library off of them. So right now, I think we have probably about 50 different circuit diagrams, with value sets that the user can just plop into his design, and he doesn't have to think twice about it and can start using it right away. And that's a tremendous starter helper, right? What do they call it? Hamburger helpers? Not the hamburger helpers, I'll call it a schematic helper. And just to get the users going, instead of creating everything manually, just drag and drop those circuits, populate them and place them, and then start working with them.
That's funny. Yeah, thinking about it from a hamburger helper standpoint, you have a bunch of different kinds of hamburger helper. EPLAN is the hamburger. You just drop it in whichever box of hamburger helper you want, and that's what you're going to get. That's actually it's kind of cool. I wish I would have thought of that.
We're going to see something on LinkedIn like in the next week about
probably.
And just don't forget, I was born in Hamburg, so I am a hamburger, right?
You are in Hamburg. That's right. I forgot about that. Another question: how can system integrators who are billing their customers by hour justify this time after the project to go through and define what macros are?
I would love to take this just because I've worked with system integrators, and it's always that argument, right? Is we don't have the time to do this. That the fact is, you're spending the time. So if I'm sitting in front of a system integrator and they say we don't have the time to do this after a project, you're already spending that time in the project on the errors and the mistakes that were made, and they can back up and say we don't make any mistakes, But the truth is, out of the dozens and dozens of system integrators that I've worked personally with, they all made mistakes. It's just whether you could see them or not. Those were there. So I think the justification isn't that we're going to magically give you a whole extra day in your year that other people don't have that you can catch up. It's prioritization of you have a responsibility here to improve your process and do the best you can for yourself, for your company, for the people who work for you. And you're already spending those times in ways that isn't as efficient. It's a great opportunity to relook at that and get it to a point where those mistakes aren't affecting you and the customer. And the idea is that, maybe this is a new concept, right? But there's entire industries built around this concept of breaking things down to simpler chunks. So if you look at, say, the process industry, right, and you go look at ISA 88, or what in the US we say S88 batch, that's exactly what they do. They take a process environment, a suite, and they break it down into a unit, then they break it down into equipment module, then they break it down into a control module, and they use that to build everything. So there's really not an argument to come back and say, we shouldn't do this. This isn't, a best practice, or we don't have the time.
Absolutely, absolutely. And the other thing, which is interesting too, but billing by the hour, my experience has the companies that we tried, or that we implemented EPLAN and they used to bill their customers by the hour, are the people that did not want to implement EPLAN at all. Because EPLAN was making them so efficient that they weren't able to build the same amount of hours that they used to. So it became a bit of a challenge, because now
So they switch to fixed price.
they would either have to find new business to justify the lack of income, or they would have to find another way of billing hours to their customers. So it's kind of
I think that this is the way I've always done it, though. It's being comfortable with doing a certain process. I was editing a video just the other day, and I wanted to use some kind of effect, and I thought I could do it on my own. And I spent probably 30 minutes to an hour trying to get it, and it kept crashing. And I didn't understand why it wasn't doing the thing that I needed it to do. So I pulled up a video to show me how to do it. And within 3 or 4 minutes, I did it. It didn't crash, got the video out, and I was done. Because there are simpler ways to do it. And that was the correct way to do it. Because I saw it in multiple videos. This is how you do it. Don't do it your way, because there's something with the software that doesn't agree with how you're trying to manipulate it. And that's why it crashes. But we just get stuck in our own head sometimes that, this is the way I've always done it. Well, it's the software's fault. It's not my fault. It's their fault. It's not my fault. I didn't mess up. They did. And so that's why we don't want to do things, because again, it gets uncomfortable, and we don't want to be uncomfortable. We like what we do.
People are creatures of habit, right?
Yeah, absolutely.
Just in our nature, we're just used to doing something, comfortable with it, and keep going. And a lot of times, there was a story actually. One of my ex-colleagues that used to work with EPLAN, he always said this story about him visiting his parents in Phoenix, Arizona, and he would fly into the airport, and he would rent a car, and he would take this highway and then just go to his. It would take him about 40 minutes. And one day he showed up at his parents, and parents says, "Hey, how you doing? So how long did it take you to get to here?" And he says, "Well, it took me 40 minutes." Like, what do you mean 40 minutes? It should take you just 5 minutes. I'm like, why? Well, they built a new highway right behind the mountain, and it cuts everything. It takes all the traffic out, and you can be here in 5 minutes instead of 40. This is, I had no idea. And he just kept on doing the same thing, and he didn't even have the idea of looking, is there a better way to get to my parents? And for me, it was an eye opener and a perfect example of doing these things over, because just we used to it, and we don't think of always questioning our methods, questioning the way that we do things, and looking at new options, new technologies to be able to help us do things better, right?
So we should tell customers, stop using GPS that you stick on your window that tells you the exact route to get somewhere, and use Waze, which is going to help you get there faster.
That's right.
Because that's what EPLAN is. It's the Waze of the GPS world. I mean, we all remember those old ones that you would stick right there on your window, and it just told you the straight. It didn't tell you anything about traffic. It told you exactly the way to get there, and that is it. It didn't take any construction in consideration. There's an accident. Look, I know a lot about this. I live in Houston. There's accidents everywhere in Houston, and there's traffic all the time. But EPLAN is the way of doing things. Way more efficient, way faster, going to get you there on time or a lot sooner than if you're just using that antiquated system, right? So
I like your analogy. It takes the traffic jams out of controls design. EPLAN removes the traffic jams. I like it.
We kind of work these things out on Open Line Friday, you know. We find talking points along the way. But really, let's talk about EPLAN's approach or total like different things that we do on our approach to standardization overall. And I know that we've mentioned some already. That's you, Sean.
we have mentioned some already, and again, our approach is, I mean, again, we have the solution and we have the tools to help customers standardize. I think that's the first step. The second step is really getting the customers' eyes open, you know, be open to change, be willing to improve in your processes and looking at ways to do things better. Another approach is norms and standards. And I know when we talk about norms and standards, people are very reluctant to even look into them because they always look at it as a pair of shackles, right? It's like, I can't do this because the norm tells me to do this. But there are certain norms that are really incredibly helpful in standardizing and providing that organizational environment. And one of them is the IEC 81346. It's not a European. People have a misconception. IEC, they always think Europe, right? If you say IEC, I'm sure Eli, and you probably heard that. It's like IEC, oh, that's a European thing, IEC, right? But IEC stands for International Electrical Committee or Electrotechnical Committee, and it's international, means it's worldwide, and there's no reason why we should not apply IEC standards also here in North America. And if we look at the IEC 81346, it gives users and people that implement that a really nice way of organizing their data. It tells you, okay, I've got an object, I've got a motor, and it's asking you three fundamental questions. What does this motor do? What is it for? And what is it? And once you answer those three questions, it gives you a whole new perspective on how you can label it, how you can tag it, how you can create structures in your machine according to function. So now we're talking about functional design, and it's really nice. And it doesn't, it transcends boundaries. It transcends languages. It transcends cultures. It really provides a nice foundation to be able to standardize upon. And I think a lot of users, if they have not yet, you know, take a look at it, have a look at what the principles are, and if you can apply them, because they're really nice. And of course, EPLAN supports that 100%. So it's really a no-brainer.
Now, as much as we've talked about standardization, how do you set that up? You know, what do you do to get this going if you're a company that has been doing things the same way over and over? You know, what would you tell a company, hey, this is your first step. This is what I want you to do before you even think about anything else, because you have to set up some kind of system in order to get to that end result.
Absolutely. And I'll say it. It's what I tell all my customers is create the first project. The first project is your baseline. So in that first project, take your time. You'll probably take longer than you normally do all of your existing projects because you're so familiar with your CAD environment that you just kind of know exactly where everything is and pull things pieces here and there. But then you spend your time fixing those. But just create an initial base project in EPLAN. And once you have that project in EPLAN, now go back over that project page by page and identify which areas or which sections of that schematics am I going to be reusing. Which schematics can be standardized and reused, and then put those in a library. And then you start building your library. So now let's take the second project. Now I already have a library. I've already got a power supply. I've already got a motor starter control. I've already got a PLC input card. And all of those, now you just kind of start building your second project by dragging and dropping those pieces and now making small modifications here and there. As soon as you make modifications, can I plug these modifications back into my standard? can I update my library of standards to be able to support that modification that I just made? And most of the time, the answer is yes. So then you can start adding those. So every project you do from there is going to go faster and faster, and your library is going to be stronger and stronger based on those standards. So it's really not pie in the sky. It's practical approach of implementing, the first initial project in EPLAN, and from there breaking it down into the common denominators, the common pieces that you're going to be reusing over and over again to build the new projects.
I'm going to put both of you on the spot right now a little bit. Do you have any aha moments from a customer? I mean, besides the obvious, the 40 hours to 15 minutes, but what aha moments whenever you're talking to someone, they're like, look, this changed everything for us?
My aha moment has been not necessarily on the spot at the customer. It's been 6 months later, because in those 6 months they've been kicking and screaming and saying, "Oh, this takes us longer. It's harder to implement, and yeah, it doesn't do this. I could do it in CAD. I would have been a lot faster. It would have been done by now. But here I'm fighting with all these things in EPLAN, this and this and that." And I'm like, okay. So after 6 months, I go back to the customer and says, okay, you complaining about EPLAN that it wasn't doing what you want. I'll take EPLAN away and you can go back to AutoCAD. And then they're like, no. I don't ever want to go back to AutoCAD. It's like the efficiencies that we gain within those 6 months are so massive that it's like, I don't ever want to do a control design in AutoCAD. And for me, that's been kind of the repeated aha moment that I've always experienced at customers. And it takes those 6 months to realize. It really does. And some customers, it actually even took longer. I mean, we've got customers that says, it took me 6 years to realize how much different EPLAN was to my CAD environment that I was using. But now it's like, I never, ever want to go back. So some people define it quicker, some people faster. But at the end of the day, it's really once they change and they start seeing the benefits of EPLAN, they never ever want to do things the old way, which is I think a testament to the power of the software solution.
For me, it was we were doing kind of a technical review of EPLAN with someone who did AutoCAD trainings, but they also did other things too, SolidWorks trainings and things like that for their customer base. And there was a comment in there where they were just like, okay, well, we know that it's better. Like, we all know that it's better, but we just want to be able to highlight those differences and details. And I thought, how interesting that it wasn't, it's better in these ways and it's, worse in these ways. And it was, we all know it's better. It's just, and this was a person who was first getting introduced to it. And I just found that very strange that was the comment that she made. And then one other that is not really in line with standardization, but in line with EPLAN was, we were at a facility who was the most advanced AutoCAD electrical user I've ever seen. And they had a pretty advanced panel build operation. And we were talking to them about smart wiring and those types of things. And they're just not interested at all, right? Because they have everything down. And they had a great process. And then as we were walking by the panel shop, after the panel shop pretty much told us not interested in smart wiring or anything that we had, they had to print a whole new set of schematics because they had some red lines. So they had printed this big stack of schematics and had set it on the table. And as they were turning, they hit it. And all these papers just went like all over the floor and highlighters were rolling off the table. And I thought, there's an aha for me that there's such a better way sometimes than what you're doing.
Yeah, it's hard. I think it's hard for people sometimes to realize until they get their hands in there, till they start getting their hands dirty. And then they understand exactly, what the difference is. And we have a lot of those moments on our Open Line Fridays. We have a ton of great stories that we've heard. Roger told some last week, and we've had Alessandro even tell some before about being, I think it might have been Alessandro I don't remember who he was with. Oh, Paul Galiniak, where they had moments where they were with a customer and then there was a problem somewhere. So they had to drive out for 30 minutes, everybody in their own vehicle, 8 vehicles going out there. They were there for 2 hours. figured out what was going on, had to go back to the office, another 30 minutes, everybody driving. You're just spending so much time and effort and money whenever the solution is right in front of you. And that's got to be great for Alessandro or anybody on the sales team and say, okay, can I say something without you getting offended? We could have helped you here. I mean, and so I guess from the channel side, a lot of this is you probably get a lot of stories that come in the same, just like that, Eli, from some of your great contacts in channel that tell you about these moments, because they have that, they have the customers that are coming back to them and telling them stories.
Well, we've had them, I mean, happen live in the meeting with the customer where, maybe out of a courtesy, we brought the distributor in and was talking to the customer, and the salesperson was, yeah, I'm sort of interested. It's another product, right? That sort of thing. And then you kind of see them kind of start to lean in and listen and be like, wait a minute. And I remember this one in particular, I got a call from the branch manager of a distributor who had just sat through a meeting. He said, let's go, man. He said, I am ready to go. He said, I had no idea that's what y'all did. No, I mean, he was so empowered and encouraged to go out and spread that message because he didn't know it existed. To him, everybody was just doing what they knew to do. You use AutoCAD, you use SolidWorks, you use what's available. They didn't know it was a better way. And then to find out, I mean, a little bit of a redemption feeling when you experience that.
We just had Anya, she's in our professional services. She's one of our engineers. We had her on a panel yesterday for automation ladies. And she talked about, and I know that she doesn't have the same amount of time as you, Sean. You've been here for almost 30 years. She talked about almost being with EPLAN for almost 20 years. And somebody wrote in the chat, EPLAN's been around that long?
Yeah.
It's just, I think that's the difference between in the States and in Germany or in Europe overall, that in Europe, they have been using EPLAN for a long time, and they're still over here in the States learning who we are and the capabilities. So these talks are always good for that.
Just, do you know what a 5¼ inch disc and a 3½ inch disc is? Those old little disc drives.
Yeah,
that's how EPLAN used to be installed. We used to have those
zip
little
drives
diskettes.
before your zip drives. Yeah,
it was like 10 of them, and then you would just play disc jockey, right? Swapping those discs out, installing EPLAN. And then there was also, we had a small monitor. It was a 13-inch, and then we had a 21-inch, and the graphics were on the 21-inch, and the text, all of the inputs of the properties and all that was on the 13-inch. And you had to configure all of the hardware because the hardware was not made for that. So you had to actually pull out the graphics cards and take the little jumpers and switch the jumpers around so they could support those two monitors. And it was nuts. It was nuts.
You've been able to see a real evolution of the product.
Oh yeah, absolutely. Absolutely.
You better be careful, Sean, because eventually the word pawpaw is going to come out, and there's no going back after that.
It just did.
Does everybody know? Does everybody know what a pawpaw is? That's not from the South.
We've got Uncle Cruno and Pawpaw Sean.
Hey, Sean and Eli, thanks so much. I appreciate y'all being on this. It's always great information. And Eli, I hope that you'll come back like Sean does. Eli, in the beginning, whenever we talked about him coming on Open Line Friday, he said, I don't know if I can talk like that. I don't know if I can say anything interesting.
So my exact words was, were you going to be there? And, no, just kidding. No, happy to come back.
Yeah, always good to talk to both of y'all. So thanks so much. Have a great weekend, and we'll see you at the next Open Line Friday, which should be in about a month from now. This session will be on demand next week. So have a great weekend. Enjoy, and we'll see you soon.